Hello, my name is Meti Adane. I'm an undergraduate software engineering student. Over the summer, I've been working as an intern researcher at the University of Michigan with my mentors, Professor Satish Narayanasamy and Jonah Rosenblum, on a research project called Secure Federated Genomic Analysis at NSCAM. Before I proceed with my presentation, let me give you a bit of background on genome-wide association studies, or GWAS for short. GWAS is an approach used by researchers to help them identify genes that are associated with a particular disease by comparing the genetic variation between a case group and a control group. And for accurate and quality GWAS, large amount of genomic data is required. And often, this data is spread across multiple independent institutes, and due to its sensitive nature, it cannot be directly shared among institutes. Rather, an alternative solution would be for these institutes to collectively agree on a trusted third-party entity to receive this genomic data, perform computations, and send back only final results without having to reveal any of the data to anyone. But to what extent is this third-party entity to be trusted or secure? Because with the traditional architecture of how our machines and computers are built, the operating system has the capability to view and access the application data that's loaded onto the memory by the application, meaning an attacker that's able to launch a successful attack against the operating system or a privileged code will now be able to view and access the application data. In our case, this genomic data would fall in the hands of the attacker. To prevent this, we chose Intel's hardware-based memory encryption solution, SGX, which is a set of instructions built into Intel CPU that allows applications to define certain private region on the memory called enclaves. These enclaves are only accessible to certain functions and inaccessible to the rest of the system, including the operating system, meaning that even if the operating system was compromised, the attacker will not be able to view this genomic data, and this genomic data would stay safe. While SGX solves the aforementioned security issue, it also adds additional computational overhead to the system. And our main goals here in this project is to reduce the overall runtime required for GWAS in SGX. And for that, we proposed design and enclave-specific optimizations. By distributing computation across multiple cores and by representing allele data by fewer bits of information, we were able to reduce the overall runtime required for GWAS. And by grouping data by allele, we were able to bypass the memory limitation induced by SGX. And for enclaves optimizations, we noticed that most calls were being made to load data onto the enclave and to send back final results out of the enclave. And for that, we used batching to help us reduce the number of system calls that were being made. And we also organize our patient data to maximize cache spatial locality. By using these optimization techniques, I implemented a third kernel that handles chi-square test for GWAS. A chi-square test is a statistical test that is used to compare the observed results with expected results. I also implemented a sample genomic data generator that was used to test the performance of this kernel. By fixing the patient data set size to a few hundreds and by varying SNP data set size, I was able to observe the runtime for chi-square test for GWAS in SGX linearly increases as the SNP data size increases. For the next phase of the project, I'll be testing the system for scalability for variable patient data set size and apply further optimizations. In conclusion, GWAS requires vast amount of data, which is often obtained through a federated approach. And by systematic design and enclave optimizations, statistical tests up to millions of SNPs is possible for GWAS in SGX. Last but not least, this had been a wonderful experience where I got to work on my collaborational and reasoning skills. And most importantly, it gave me insight into research and how research is conducted. Thank you.